Welcome to our next topic, safe lean agile principles. So safe is basically based on 10 lean agile principles that guide the development of large scale systems in lean agile manner. These principles provide a foundation for safe and help organization in achieving better business outcomes. Let's have a look at all of these principles one by one and see how these applies to various scenarios. The first, um, the first safe principle is take an economic view. This principle emphasizes that decisions should be taken based on economic consideration and that the primary goal of any development effort should be delivering value to the customer. So what it means is that whatever work we are doing uh, as part of our agile team or agile release team, whatever decisions we are making, they should all those decisions should be taken keeping economics at the heart of every decision. For example, if we are developing a new software feature, then the product owner or product manager should consider that what is the cost of developing this particular feature, how much revenue will be able to generate by delivering this feature, and what will be the impact on customer satisfaction. So we have to consider all these kind of things, basically the economic perspective of spending any money and what is the advantage or benefit we are going to get by spending or investing this money. Then the next point we should consider here is we should deliver each and every feature early and often. So what does that means is more earlier we deliver any feature, that means more value our customer are going to get from it. That's the core idea of it. And more you delay the delivery of feature, the value which the customer is going to achieve from it will keep on reducing as the time passes. So that's why we should deliver more early and more often. And more, why we should deliver more often or more frequent is because by delivering more often or more frequent, we uh, uh, we get an opportunity to get feedback from the customer on this feature, and then we can use that feedback uh, and apply on the next iteration of our product, and basically keep on improving our product cycle after cycle. Then the next principle is apply system thinking. So this principle encourages us to think about the system as a whole rather than focusing on individual components. So what does that mean is basically what whatever there is a very famous quote from Deming, um, which is a system must be managed and it will not self manage itself. What it means is if any component is left to themselves, it will become selfish and competitive, and it will become an independent profit center, and then it will result in destroying the system. And the key secret is for a system to be successful is cooperation between all of these components. That should be the aim of every organization. So the um, the aim of every organization should be cooperation between all these in individual systems, which will result in basically better value for the system as a whole. another reason why we should consider system thinking is because um, when we are optimizing a customer, that doesn't necessarily result in optimizing the system as a whole. For a system to behave well as a system, a higher level understanding of behavior and architecture is required. The value of system passes through its interconnections. A system can evolve no faster than its slower component. So whenever we are trying to optimize a system, it will not necessarily result in optimizing the uh, so whenever we are trying to optimize a component, it doesn't necessarily will interpret into optimizing the system itself. That is the first key point we should be thinking. The second key point is, for the system to behave as a well system, we need to understand the entire behavior and architecture of the system. N- uh, no knowledge of component is not enough. The value uh, of a system passes through its interconnections. The system can not involve faster than the integration points. Apply system thinking. So this principle encourages us to think the system as a whole rather than individual components. And when we are designing any big system, then the various teams which are working on developing this system should be well aware of not just the component on which they are working, but they should be aware of the the system as a whole. For example, let's say you are building a human like robot, right? And there are n number of teams who are working on building this human like robot. And one of the imagine this one of the team is building the fingers of this human like robot. Another team is working on building the palm of this human like robot. Another team is building the face which will have the mind of this human like robot. So uh, let's assume the team who was supposed to build the fingers haven't have already built the fingers without knowing that they have to be integrated with the palm. And in that case, what will happen is, at the point when they try to integrate these fingers in the palm, the integration will not happen properly. Also, because this palm and face, which is having the mind, they have to work together as a system as a whole, right? So if these various teams who are working on these various components of this human like robot, they don't understand the system as a whole, they don't know the architecture or behavior of the human like robot system, then they will not be able to uh, build this human like robot properly. They might be able to build good components for their individual teams. So for example, the team which is working on the fingers, they might build good fingers, but that might not necessarily result in building overall good human like robot. So that's the core idea being conveyed here. The next principle is assume variability and preserve option. So what this principle is saying is that this principle basically acknowledges that the variability is inherent in any development process. Why? Because we are there whenever we are building very complex systems or product. In those cases, we don't know what will be the solution looking like. Why? Because we don't know the problem fully, we don't understand the requirements fully, we don't have enough information. So the information will evolve, the requirements will evolve, and so because all of these things will evolve, that means the solution will evolve over a period of time. And that's why uh, there is a inherent variability in the development effort, and um, because of this inherent variability, we need to preserve our options. Why safe have introduced this method is because in waterfall approach, what we used to do is we used to have a point based approach. In the point based approach, what we will do is we will um, decide the solution option which we are going to take forward very early in the process, and what it will result into is that till the point we will actually know what should be the right option, it will be already right, because we we decided the solution uh, option very which we are going to work with very early in the process, without even knowing the full requirements, without even having the full information which is required to take this decision. And that's why the solution option which we have stuck to in this point based approach, which is a waterfall approach, uh, will be far away to the right solution which we needed. And for that reason, safe is recommended to go with a set based approach. What is a set based approach is we start with multiple design options, and we keep these multiple options are open until we have more enough information to reduce the number of option which are suitable to our situation. And then basically let's assume you started with five uh, five options, which is basically one set of design having five option. Started with five options based on the requirements or knowledge you had, and you kept working on these options or kept these option open for a month. After a month, new knowledge emerged, new information emerged, which was enough to uh, narrow down the solution options to two. So now you are working with two solution options. Now you kept working for another month or say a few weeks with two solution options, and then new uh, information or knowledge emerged, and based on, and now this new information and knowledge is enough to narrow down this solution options from two solution option to one. And at this point you come to one solution option. So using this set based approach, what you did is you kept your options solutions options open uh, till late enough stages where you had enough information to decide where what is the right option for you, and you chose the right option based on good amount of knowledge. The next safe principle is build incrementally with fast integrated learning cycle. So, this principle encourages us to build system incrementally and to integrate them frequently. For example, let's say a software team is building a human-like robot, like the example I was giving you before. So, we instead of building this human-like robot in one go, what we do is we build it step by step. Let's say we build this hand first. Let's say in that also, so we build these fingers of this human like robot first, and after building these fingers, we build the palm, and then we integrate these fingers in palm. And when and what we are doing by what we are achieving by doing this is that we are building the human like robot in tranches rather than in one go. And what it results in doing is, when we first build, let's say, a finger and the palm, and then we integrated it. Now, during the time of integration, we know what is the problem which is coming during the integration, and we can solve that problem rather than keeping it delayed for a longer time. This way, if we keep in uh, uh, integrating system components more frequently, that way we will it will become less complex for us in long term. The integration will become less complex for us in long term. Then the next safe principle is base milestones on objective evaluation of working system. So the key idea of this principle is, basically, this principle emphasizes the importance of objective evaluation of working system to determine whether uh, the system meets the desired requirements or not. So why safe and introduce this safe principle is because what used to happen in waterfall is we used to have this phase gates milestone. For example, we had milestone around requirement completion, we had a milestone around design completion. And what it used to do is, when you have uh, milestone around uh, basically in waterfall, what we used to have is, we did not have milestone around working system. We used to have milestone around requirement completion, design completion. And what they used to do is, these kind of milestone used to force us to take a lot of decision too early in the process, even without having enough information. And what it resulted in doing is, this resulted in having false positive feasibility. um, Basically, we used to show uh, um, false success, because even though the requirements are complete, but we haven't delivered the working software, and we don't know whether these requirements are enough for the solution, for the component or not. So that's why safe have suggested to base the milestone on the evaluation of working system. So if you have what it means is, basically, uh, the success is evaluated, or the milestones are established based on uh, the feedback of customer, the performance of product and solution in the minds of customers, and the progress or milestones are based on the progress uh, of the objectives which we have agreed during the PI planning against the team and ART level backlog. Make flow without interruption. Make value flow without interruption. So this principle focuses on importance of delivering value to the customer quickly and efficiently. Um, To achieve this principle, SAFE have recommended 8 flow accelerator. First one is visualize and limit work in progress. What is if there is too much work in progress, what it will result is it will create confusion around what is the priority. It will increase the overheads, and um, the next principle is apply cadence, synchronize with cross domain planning. So this principle encourages us to establish a regular rhythm for development activities. For example, by following by applying cadence, what we do is we um, convert the unpredictable events into predictable occurrences, and we reduce the cost. For example, in SAFE, we have these iteration planning meeting, daily sync meeting, iteration review, and retrospective. And all these events will be happening in a rhythm, iteration after iteration. So all these events will be predictable, and it will reduce the unpredictability in the events. And it makes the waiting time for new work also predictable, because we know that we are going to have um, 2 week iterations. That's why the waiting time for new work is predictable, which is 2 weeks. It supports regular planning and close functional coordination, and it help us in reducing the batch sizes to a single increment. Unlock the intrinsic motivation of knowledge worker. This principle basically recognizes that knowledge workers are motivated by factors such as autonomy, mastery, and purpose. And what do we mean by knowledge workers is basically um, uh, people like product owner, product manager, developers, testers, domain experts, SME. So anyone who is capable of designing, building, testing, delivering a feature. So all these people are considered a knowledge worker, and they tend to be expert in their own work. They are even more expert than their own bosses. And if we want to unlock their potential, their motivation, then we should give them enough autonomy. We should give them enough space so that they can become expert in their own area, and we should give them a higher purpose for which they are working. And what it will do is it will unlock uh, um, the the potential of these workers, and they will be able to deliver more value to the customer. Then the next principle is decentralized decision making. So um, this principle encourages us to decentralize the decision making and to empower team members to make decision locally. So the decisions which are more frequent in nature, for example, uh, any decision which is for team level backlog or ART level backlog, they should be decentral, decentralized, so that the team level people can take those decisions, or decisions which are time critical in nature, which can result in high cost of delay. They are also should be decentralized. For example, at what point a release should be released to the customer. Then decision which require local information, for example, um, acceptance criteria within a US story. So those kind of decisions should also be decentralized. But decisions which are infrequent in nature, or long lasting in nature, or which have significantly bigger economies of scale, those kind of decision should continue to be centralized and should be kept with more higher management. For example, decisions about internationalization strategy. So these kind of decisions are taken infrequently. So, or for example, long lasting decision. For example, what should be the common technology platform which should be used across team, or compensations strategy which involves economy of state scale. Those kind of decision should be kept still kept as centralized decision with basically the senior management. The next principle is organize around value. This principle emphasizes the importance of organizing the agile release train around the value streams rather than functional silo. So, for example, if you are working for a insurance company, how the value flows in an insurance company is basically, um, uh, for example, a software development team might organize around, for example, agile release train might organize around the user journey uh, of for example, in case of a bank, um, the um, the agile release train can organize around the user journey of the user who is basically applying for a, let's say, home loan, rather than creating functional silos such as a separate development team, separate testing team, and separate deployment team. Rather than organizing like that, we have a single agile release train which work across the entire user journey of buying a home loan product, across a cut which cuts across all the departments.